All right, hi, good day all. So we're going to be doing, this question is May, June 2021, number 3. Now this question here is usually mostly transformation, and sometimes they like to bring these shapes, right? So let's go into it one time. The diagram below shows triangle PQR. And if we look at PQR right off the bat, because of the square little line, we know it is a right angle triangle, right? In which angle QPR, that just means, guys, that your angle in the letter in the middle, that is letter P, by letter P, that is 62. The angle for PQR is 90, that is the letter by 90, by R is 90, and line PR is equals to 11. Now, if we remember for when we were doing a little bit of trigs, right, I said that your line that is opposite your 90 degrees is known as your hypotenuse, and it is also the longest side on your triangle. So this right here, this 11, is opposite your 90, which is denoted by the square, right? So we know that 11, or your hypotenuse, is equals to 11, right? We also know that in a triangle, right, it is 180 degrees, right? Everything, all the angles, all the interior angles when added is 180. If you cannot remember that, there's a formula, which is n minus 2 by 180, where n is equal to a number of angles. If we look at the number of angles inside here, a number of interior angles, I should say. Your number of interior angles would be 3 minus 2, which is 1, multiplied by 180. So all the angles inside here would be 180. So we know that this is 90. So if the axis for the size of angle PRQ, that is, they're asking for this angle here, we'll label it X, or not X, let's label it R, right? When we add everything up here, it's supposed to be 180. So it's going to be 62 plus 90 plus R is equal to 180 degrees. And we could say 62 plus 90 is 9 plus 6 is 50. 152 plus R is equals to 180. We want to make R the subject, so we're going to carry across 52. So R is equals to 180 minus 152. You can use your calculator to do this question, all right? So 180 minus 52 is equal to, this will turn to 7, this is 10, this is 8, this is 28. So we know that angle PRQ is 28 degrees, right? And that is how you would find your first answer. The second one is the length of side RQ. So they're asking for, this is 28 degrees, right? This side here. Now, to find a side of a right angle triangle using degrees, using an angle on one side, we can use the formulas which is SOHCAHTOA. Now, SOHCAHTOA stands for sine theta is equals to opposite over hypotenuse, right? Cosine or cos theta is adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. Now, if we look at the question to tell you which formula you would use, they give you a hypotenuse. So right off the bat, we know that we cannot use tan because tan is opposite over adjacent and that has no hypotenuse in it. So it's either sine theta or cosine theta that we're going to use. Now, to find out the labels of the other side, if we're using 62 degrees, if we're using this angle here, then RQ becomes my opposite, right? So if I'm using 62 degrees as theta, right, I'm using my hypotenuse, then RQ now becomes my opposite the angle that we're using, right? So if we have opposite of a hypotenuse, right, we know that theta is equals to 62. Let me make sure I don't want to make any mistakes. Right, theta is 62 degrees. Your hypotenuse is equals to 11, and we're trying to find your opposite. So that means we will use sine. So you're going to put sine 62 is equals to opposite over hypotenuse, which is 11. We're going to make our opposite our subject of our formula. You carry across 11, so it's 11 sine 62 is equals to your opposite. You're going to put this in your calculator. Now, guys, when you put this in your calculator, you need to make sure that your calculator, before you write any number, you just need to make sure that your calculator is on degrees. If it is not in degrees, that is your calculator has a little image called DEG on top. So if you look at your scientific calculator, when you press on, you're going to see something called DEG. If it is not there, then you need to put it on there, right? So you're going to put 11 sine 62, and when you put that, you're going to get your opposite is actually, so opposite or RQ or RQ is equals to 9.71 to 2 decimal places, sorry, centimeters to 2 decimal places, and that would be your answer. Now, if you was using 62 degrees as your angle. Now, if you didn't want to use 62 and you want to say, well, I want to use 28. If you're using 28 here, this side now becomes your adjacent. It is not your opposite. It becomes your adjacent, and that the formula that we would be using if you're using 28 as your degree would be cosine. So it depends on which angle you're using. So if you are using theta is equals to 28, right? Your hypotenuse is equals to 11, and your adjacent is equal to RQ, right? So you're going to use cosine, right? So it's going to be cos theta is equals to adjacent over hypotenuse. So it's going to be cos 28 is equals to adjacent is RQ divided by 11, and we're going to make RQ the subject. You're going to carry across, divide by 11 over the equal sign. It's going to turn to multiply by 11. So it's 11 cos 28. And remember, same thing with sine. You have to make sure that your calculator is in DEG, right? So you're going to put 11 cos 28, and you're supposed to get the same answer, which you do, right? Which is equals to 9.71 centimeters to 2 decimal places. And that would be your answer for the length of RQ. So the only thing that it depends on is, guys, what angle you're using. So if you're using 62, your RQ is your opposite. And if you're using your 28 degrees, your RQ becomes your adjacent, right? And those are the two ways to do this question. Right? Now the next question, part B, is the diagram below shows 3 triangles, X, Y, and Z on a square grid. So we're going to see, we see X, Y, and Z. Right? Now X, Y, and Z. So triangle X is mapped onto triangle Y by ray reflection. State the equation of the mirror line. So first off, we're looking at X and Y. So this is X and this is Y. So what you're going to do is you're going to count the distance from your X, from your two objects, and your object and your image. So I'm going to take a coordinate. You're going to count. It's 1, 2, 3, 4. So I know that my distance from my object, which is X, to my image, which is Y, is 4 units. To find the location of my mirror line, I have to divide 4 units. So I'm dividing 4 divided by 2, which is equal to 2 units. So my object is 2 units away from my mirror line. So it will be 1, 2. So now if we look at it, we know that my mirror line falls into the the line of where your x-axis, this is this line here. I'm going to put this a different color so that we can see it. Right, I'll put it red. And this line here, this is where y is equals to 0. So when they ask for the equation of the mirror line, the equation of the mirror line would be y is equals to 0. Then they said, the next one, they said, describe fully the transformation which maps triangle X onto Z. Now, if we compare X and Z, we see that there are 4 different transformations. This is not an enlargement. It is not a reflection. It is not a translation. This is obviously a rotation, right? Now, as soon as we know that it is a rotation, we're going to write it's a rotation. Right? And we're going to let me just get some space here. All right, so if we know it is a rotation, what we're going to do is right at the side, as soon as you hear rotation, you're going to write the 3 things that you need to describe a rotation. To describe a rotation, you need 1, your center of rotation, 2, the direction of your rotation, whether it be clockwise or anti-clockwise, and 3, you need your degree. The degree that the object rotated. And for rotation, you need your protractor. Okay? So first off, we're gonna say triangle X rotated to form triangle Z in a something direction. I'm going to fill it in something direction about in a something direction in a something direction, so how much degrees, right? About the center of rotation, and this will be our coordinate. So I'm just filling it in. So when we figure out each thing here, we'll put it in. So let us look at this now. Right, so this is what we have here. The first thing you're going to do to find your center of rotation is you're going to connect 2 corresponding points. So you're going to connect this point here. Let's connect these 2 points, this point here and this point here. All right, I'll make it bigger so you guys could see. Right, and then the next thing you're going to do is you're going to take your next line, right, and you're going to connect a next 2 corresponding points. This corresponded with this one here. So we connected 2 corresponding points. Then we have to find the middle of these lines, and we can see the middle of this line is right here. Again, find the middle of these lines. So you guys will have your rulers, so it's easy for you to find. So your middle of, my middle is 1, 2, 3, 4, 5. It's right here. Right, and the middle of this line is 2, 4, 6, 8. So this is 2. So 2, 4. So that's right here. Right, so these are the middle of that line. Those are the middles of the line. Then after you find the middle of the line, then you're going to line up your protractor to write the perpendicular bisector of those lines. Right, so we're going to line up our protractor, right, our protractor with this line here, where your T at your protractor is going by a black point there. Then you're going to take your shapes, right? Let's take your shapes. You're going to draw a line that is 90 degrees. So I'm just going to draw it and elongate the line. So let us just draw it. Let's make this a little bit bigger so we can see the line. Right, and then the next one, we're going to make a perpendicular bisector of this line here. And then we're going to insert the image. We're going to draw next line. Right, let me just fix it so it will line up to 90 degrees. Right. Make this bigger. Alright. I'm just going to make this a different color so we can see it better. Right? And guys, where this intersect, where these two lines intersect, which is, as we can see, they intersect at 0, 0. This is where 0 is at, right? So the point or the center of rotation here will be 0, 0. Right? So then after you find that, then you're going to join two other corresponding points. That is, we're going to insert a line. We're going to join two corresponding points to the center of rotation. So let's take this point here, right? And you're going to join it to this point here, right? And then we're going to make this a little bit bigger, right? Then you're going to take a next line. Connected to the center of rotation. Let's make it bigger, and then we're going to put our protractor. All right, so we have that. Then we're going to take a protractor and line up those two purple lines, right? And we're going to see how many degrees it is. And if we look at it carefully, we can see that this, oh, hold on, undo that. We can see that this was rotated 90 degrees, right? And because it's going from X to Y, this is going in an anti-clockwise direction. So now we're going to fill out everything that we have here. We found out the center of rotation to be 0, 0. We found it, the triangle, it was in an anti-clockwise direction. 90 degrees about the center of rotation 0, 0. And that is how you would describe transformation rotation, right? Yeah, so that is how you would do part 2. Right. Part 3 says on the diagram on page 10, that is just the graph, right? Translate triangle Y using vector -7, 1 and label the image V. Now, remember, there are two ways to do this, right? -7, 1, right? So, and it is triangle. What triangle? It is triangle Y, right? So, we're going to go to -7, 1, right? So, we're going -7 along your x-axis. And I said if it is -7, you're going to your left-hand side. So, you're going to take one coordinate and we're going to go 1, right, so we're going to go 1, 2, 3, 4, 5, 6, 7. So I know now that my coordinate is going to be right here, right, for this one. And then we're going to do the same thing for next point. 1, 2, let's do it so you guys could see it. 1, 2, 3, 4, 5, 6, 7. So this coordinate is now going to come here. Hold on, I didn't do +1. So it was 7, negative 7, and 1 unit up. That's 1, 2, 3, 4, 5. So it's somewhere here, right? And then this one, same thing, was 1 unit up. I didn't do it. So it was negative 7 along your x-axis and positive 1 along your y-axis. So that is 1, 2, 3, 4, 5, 6. So that is right here. Right? And then this one here, this triangle here, you're going to go 1, 2, 3, 4, 5, 6, 7, and then 1 unit up, which is 1, 2, 3, 4, 5. This is right here. Right? So this would be your image for after a translation of minus 7, 1. So let me just connect the lines, right? And for you guys to see. Right? Hold on. To see it. And they said to label this as triangle V. So we're going to label it as triangle V. Now, this is one of the ways to do it, guys. There's another way, and another way is you take the coordinates of Y. So this one here is it's along your x-axis. So that means it would be 0 minus 2, right? This coordinate here would be 6 minus 2. This coordinate here would be 4 minus 4, right? You take these coordinates and then you turn it into column vectors, right? So let me just, so this is for part 3. So part 3, right? We know it is your object to your image, right? And your object to your image has to undergo a translation of minus 7, 1, right? We're going to take the coordinates of our object, turn it to a column matrix, and then add it to our translation that they gave you to get your coordinates for your image. So let me just check it back. That's 0 minus 2. So my coordinate of 0 minus 2 will turn into 0 on top minus 2 at the bottom. Then we're going to add minus 7, 1, right? This is equal to minus 7, and minus 2 plus 1 is minus 1, right? So my coordinates for my image would be minus 7 minus 1. And if we look at this here, let's just check and make sure. If we look at it here, we will see that this coordinate is definitely minus 7 minus 1, right? The next one is 6 minus 2, right? So 6 minus 2, right? We turn it into a column vector, 6 on top minus 2 at the bottom, right? Then you add your translation, which is minus 7, 1. 6 plus minus 7 is minus 1, and then minus 2 plus 1 is minus 1. So my coordinates for this, for my image, is minus 1, minus 1. And if we look at it, let's look at the triangle to make sure that we did it correctly, right? If we look at it, you're going to see this is definitely minus 1, minus 1, right? And then the last one was 4 minus 4. So you're going to take that coordinate of 4 minus 4, 4 minus 4. You're going to turn it to a column vector of 4 on top minus 4 at the bottom. You're going to add a translation of minus 7, 1, right? So that's 4 plus minus 7 is minus 3, and minus 4 plus 1 is minus 3, right? So this would be negative 3, negative 3. And this right here would be my coordinates for the last one. And if we look, this is negative 3, negative 3. So we get our image V. This is the two ways that you would do this question. Now the last part is on the diagram on page 10. Enlarge triangle at about center C00 and a scale of factor of a half. Label this image W. So we know that they said that it was, which triangle are we triangle X is the enlarging is the enlarged image. So we're going to look at triangle X, right? And we're going to connect these coordinates to the center, which is 0, 0. Remember, they already gave you your center of enlargement, so we're going to connect them, right? So we're going to connect this here, right? And then we're going to connect this one here to this one here. Then you're going to connect this one to this one here, right? I wonder if I can make this a different color. Hold on, let's see if I can make this red so we can see. Not red, not red. Let's make this yellow. All right, this one, let's make it yellow. All right, so we'll know that this is the transformation that we're talking about. All right, this one here is yellow. We already know that the center of enlargement is 0, 0. They told us that. So now what we're going to do is we're going to form a triangle that is within these lines, right? And your scale factor is a half. So what you're going to do is you are going to look at the size of one of these triangles. So the size of this is 2 units, and they said the scale factor is a half. So therefore, you want a triangle that has a half of 2 is 1. So we're going to look at the distance from this line to this line. You're going to only want 1 unit. So it will not be here because that's more than 1. So most likely my triangle is going to start here and end here, right? This is the image. This will be for the first line, this first side here, right? Then we're going to connect this line here with this line. This is 4. So we want something that is 2 centimeters long. From this line here to this line is supposed to be 2, right? We can see that, right? This here to this line here is 2, right? And then, hold on. Right. And then if we connect this line with this line, we see that that line, half of 4 is actually 2. So let us just make this a little bit further up. Make this like here, right? So this triangle here, they said to label it, what they said to label it as W, I believe. Let's just make sure, right? That here would be our enlarging factor. Let's make this the yellow so that we can see. Right. Not black. All right. So guys, this triangle that you're seeing here is W. And that would be your image after that. Sorry, that is your object that was enlarged to form X. All right. And that is how you would do this question. Denoted by the yellow. Right. And that is the end of May, June 2021.